So please run Fiji, and then we try to do together. So in Fiji, okay, you see my my screen, great. So the first thing to do is help, update. So you should do this like regularly to update all these plugin, all these 1000 plugin inside Fiji. So you see, I do the updates regularly, so my Fiji is up to date. So, but you have this thing, manage update sites. So I'm sure you already used this thing already. So here's like, because you have the basic Fiji plugins, but you can add additional plugins. So of course you have ImageJ that you have to use this one, ImageJ Fiji, you have to use these two plugins, these two package, these two update site, of course. I suggest you Java 8 should be also checked by default. And then you have this one, 3D ImageJ Suite. Just click here, check this box. If you, I'm not sure I can, yep. If you check, you will see, blah, 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 these three install. I don't want to install, okay? So, and then you need this one, and you will need also this one, image science. So you need to check these two. 3D ImageJ Suite on image science. Maybe in the future we will remove the link to image science, but now we need this one. So I may also suggest you maybe IGPB plugins. So it's quite similar to 3D ImageJ Suite, but more focusing on 3D mathematical morphology. And then usually also use like a CLIG and CLIG2. That's quite interesting because you can do like a lot of processing and segmentation using the GPU, if you have a GPU graphic card on your computer. So it's, of course, faster.
Thomas?
Yeah.
There's someone is struggling with updating. So Florence said that she clicked on the update ImageJ, but it says the manage update sites did not appear.
Is it Fiji?
She mentioned ImageJ, so I don't know if Florence, are you in ImageJ or Fiji? Maybe Thomas, you can. Fiji.
Yeah.
She's in Fiji, yeah. And he also has problems mentioning that he's running on Mac.
Oh, too bad. Oh, sorry. I'm just kidding.
I think I had the same problem.
Okay, we start again. So when we do help update, everything fine, right? Ah, yes. If you didn't update like a long time ago, the problem is like the updater itself need to be updated. So if you have problem updating Fiji, you may need to download it again. So yeah, I don't know if it's like you didn't update Fiji like the last 6 months, the updater changed, so you may need to update Fiji, the full Fiji. So okay, so for people, if this thing is working, just we stick to this, and then I will show you in 1 minute how to do without this update thing, right? But if you have problem,
Florence is happy now.
Okay, everybody happy? Anyway, I will show you how you can do without the updating. So for the updating, you should have a 3D ImageJ, a couple of plugins here. Just apply, and you should get it. And then you need to close your Fiji and then run again. If the other way is just to go back to the website of 3D ImageJ Suite, and then you have installation, and you have this one, a zip. Actually, it's just you have only four plugins to download. You have this one, it's a zip, just unzip, and you have the image science, this one. So you need this one, unzip in your plugin directory, and this one you need to download and unzip into your plugin directory. Everybody is fine? Is okay? Yeah. I will try to. Okay. Later. Okay. So we can start just for fun. Huh? We can open any 3D image. It's not very useful, but just to have a 3D image. We will not use this one, just to have a 3D image. Just to show you first. So you understand all this crazy list of plugins. So for this one, you can open any images. For me, I just open sample T1 head just to get a 3D image open, but whatever. And then
Nick Pasternak still have issues with Fiji, but I hope it's just opening it again. So
yeah. Once it's
tell us if you need to stop
yeah, once it's updated, you need to restart Fiji. So you should have plugins, 3D, on a bunch of stuff. So I will not maybe go in details. I can take 4 hours to go in details of all these things, but it's not really the point. So just give you the idea. The first two, 3D association, it's more like for tracking. It's kind of a new thing. When you detect some object at frame t, you detect some object at frame t+1, you try to match to do the best association, a one-to-one association between the object in one frame with the object with another frame. So this is more tracking. It's still a beta version, but you can try it if you have some data that can be tracked in time, for instance. This part is more like the processing. So 3D fast filters, we'll see later, is like filtering. So it's exactly the same as a process. So in Fiji, you have process, and then process is all the filters. So the filter is just usually basically to remove noise before detecting the object. On process filters, you have a lot of filters. On here, you have the 3D version of the filters. So we'll see the filters are just locally in 2D. We do the mean value, the average value. We can do in a 3D sphere around each pixel. We compute the median value, the average value, and so on and so on. So this thing is exactly the same as 3D fast filter here. This one is to detect edge and also a very spherical object. 3D hysteresis, this thing is more for segmentation. So maybe when we have an example, we will try to use this thing. So 3D segmentation is here. Once you have segmented, you may want to improve the segmentation. So you may want to fill some holes. You want to, this one is quite useful, to make the shape of the object like more compact. So this one is what we call closing in mathematical morphology. So the shape is quite compact. The distance map we will see is to compute distance from one object to the outside, to the border for an object to the outside. 2D watershed, we will see later is for segmentation. Starting from seed, we try to grow object around seeds. So this part is more the analysis. So we will use this 3D manager and then 3D centroid to compute the center of all the object and so on and so on. So this part is more analysis. This part is a bit more like advanced analysis, like density of object. EVF, we will see what is the EVF later. Ellipsoid fitting, you want to fit an ellipsoid to your object. And this one is more like utilities, to draw some shape, some sphere at a specific location, to draw the object you detected into the image. Okay, and then you have some things below, but I cannot see. Okay, so any question? Shall we start with a real example? Okay. So I'm not sure if you have did you download the data from the Dropbox? If you have, you should have something. So on the Dropbox, you will have plugins. So the plugins are the plugins. So basically you can download them from here. This is what I wanted to show you. You can download them from here, just put it into the plugin directory of ImageJ or RFG. And you have so this one is the presentation. This one is just some more image. In data, so you have some data, fish 1, fish 2, miscellaneous, and neurobiology. So maybe it's Nicolas will focus later on this one. And fish 1. Okay. So fish 1, maybe we can start, we start to open this one. Okay. Everything okay? Am I going too fast? No? Because basically you need to think that I'm talking to my screen. So please tell me something wrong. So we try to open sample fish mini.zip. So in ImageJ, you can open zip file. So in this one, okay. So for 3D data, this one is 4D data, image, property, see what's inside. 3 channel. So channel is like the wavelengths on your microscope. Here we have 3 channels, 3 colors. We have 65 Z, the slices, on only one frame or one time point. This thing is the size of 1 pixel in X and Y. So 110, 100 nanometer. And the Z. So yeah, I will not talk about this, but you know that for most system, especially like fluorescence microscopy, light microscopy, the Z, the resolution in Z is far worse than the resolution in X and Y. So and the calibration is different. So the size of the pixel is 100 nanometer in X and Y, but it's 200 in Z. So it's different. That's normal. All the microscopy system will give you something like this. Okay, check everything okay. So usually you need to go back to the center Z to see something. So what is this thing? So you can guess the red channel. So usually I try to image color. I use like channel tools, image color channel tools, and then I can see the way of viewing multi-channel data. So this way is a composite. That means I can see the 3 channels, the 3 colors on top of each other. If I go to color, I see the third channel in red, the second one in green, and the third one in blue. If I go to gray, okay, the three channels are gray, but so you see. So I use the wheel will change the channel. So you see the third channel is, then I can change the Z, is mostly the nucleus labeling. The second channel is more like some spot inside. If I remember correctly, it should be like centromeres. And the third one, you may want to adjust the brightness and the contrast. Image, adjust, brightness, contrast. And then you have this magic auto thing. It's working quite well. So I think this one is a nucleoli. So basically we will want to detect the nucleus, the spot on the nuclei, and do some measurement on all these objects. Is it okay? Yeah. So we will not focus yet on segmentation. This tutorial is more on analysis. We may go back to segmentation later. So, but for this data, you can see the signal is quite very good contrast. So it's not very difficult to detect. So with a classical thresholding, we can detect this. Okay. I will not go into detail, but basically image adjust threshold. And you see we can already detect the structure. So maybe as an exercise later, we will do this starting from the raw data. So now we just learn the basic stuff, and then after you can go back to this image and try to do everything from scratch. Okay, so let's say we manage to detect the object inside this image. So the nucleus, the spot, and the nucleoli. And these objects are open, file open, and then you will have C1, C2, C3. So you can see C1. So usually I use the name. Now C1 is you have the name of the image, sample fish, mini. C1 is channel 1, and then you know what's happening. 3D seg. That means the segmented data. We detected the object in the image already. So we can open the 3 segmented data. So we have beautiful 3D data, segmented data. Okay. So sometimes you just want to see side by side what it's happening. So for this, so you open all your data, and then you can use like analyze. So analyze tools, and then you have synchronize windows. So analyze tools, synchronize windows. And then you need to move this thing. Yep, come on. Yep. Okay. Synchronize windows, synchronize all. So now when you move one slider, you will move, so you will get the same Z for all the images. And you can so check the position. So what is this this thing here? Very white here. It's and this thing here. Of course this thing looks like the nucleoli. And where is this spot? This spot is touching the periphery of the nucleus. And you see here we still have some holes inside the segmentation. So we may need to fill some holes here. Okay. Question? No? So, yep. So try to organize your space. Yep. So after, yep, this one. Okay. So now we try to use the 3D manager. This is the main component of the 3D ImageJ Suite. This is how to manage your data. So you may have this thing, blah, 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 some information, whatever. So everybody should get this thing. Is it okay, or do you have some error message or something? Everybody happy?
How do we get to that again? Sorry.
Yeah, no problem. Plugin 3D. Everything is in 3D. And then this one, 3D manager. So the idea is you have the array manager when you have 2D data. So I just say, oh, maybe we should have a 3D manager for 3D data. So this one, 3D manager. Or else, here, you have a small search bar, manager, and then you have the 3D manager, array manager, and so you can use plugin 3D manager or just in the search bar. You can find what you want. It's quite useful, this one. So this thing looks like nothing, but actually it's quite interesting. So first we can do some segmentation. Maybe we'll go back to this one later. So the idea here, we focus on 3D analysis. So that means we already have the 3D segmented data. And then we want to do some measurement on the 3D segmented data that you obtain with a 3D street threading or deep learning or whatever. So now we have 3D segmented data. So 3D segmented data is something like this. So you can see the three objects, three segmented objects, and each object have different values. So this one is object number 1. If you can see here, and go back, you see value 1. So this is object number 1, object number 2, object number 3. So this one is segmented data. This is what we want to analyze. This one, there's only one object, no problem. And you see each object has a different color, mean each object have a different value. And if we just focus on this one, so maybe this one, I'm not sure, maybe it's actually 2 objects, but it was merged into one. Object number 16. So this thing is to manage 3D object. So you go back to you select your image where you have your segmented object, and then simply add image. Okay, that's it. Finish. So that means from this image, it extracted object number 1, and this object number 1 has the value inside the image 1. Okay, very simple. Of course, you can change the name of your object, rename. Okay, this thing is nucleus. Okay, nucleus 1 or nucleus 1, whatever. Okay. Okay, so what can we do with this? So the first thing, we want to be sure that this nucleus 1 is correspond to this thing. So we want to visualize what is this thing. So we need to go to this thing, live array. By default, it's off. So we just click live array on. Then after, we just need to, yep, okay, yep. Okay, so basically you select the image you want to see your object, and then you select your object. Sometimes you need to deselect, select again, just to refresh the display. So sometimes, yeah, it's not, synchronization is not perfect. So you may need to, so it's okay. So the yellow border is the border of this object, nucleus 1, in all the slices. So of course, since the object comes from this one, the array is perfect. But we can check on the raw data. So we just select up, okay, we select the raw data, and then we, yep, maybe just deselect, select again. Yeah, we need to, yeah. So it's okay, this thing is a, yeah, this thing is a bit, yeah, stubborn, so sometimes just, so you need to select the image, select the object, eventually deselect, select again. I know it's a, synchronization is not perfect, but if you're a bit stubborn, you can get it. So you should have something like this. So this is your raw data, right? And yellow is the border of your segmented data. So you can use this. I use this first for checking my segmentation. Okay, my segmentation is quite good. Of course, when it's very noisy, not sure what's happening, but yeah, else it looks quite okay. And you see, also this thing. And after, this is your, this is a kind of tricky question, biological question. Do you want this black area to be part of the nucleus or not? You have to decide. If you want to take the whole nucleus as your object or only the DNA, the real DNA for as your nucleus. You want to, but this is a biological question. You have to decide what you want. Of course, you can change the channel. So you have an ID first. Or of course, all my spots are inside the nucleus, but a lot of spots seems very close to the periphery. Some are in the center, some are in the periphery. We may want to have an idea if where they are. But since we are in 3D, this one looks quite far from the periphery, but in 3D is quite close. It's quite close to the top of the nucleus. So this is why if you do some 2D analysis, maybe it's a bit wrong because you're not sure where are the things. And maybe you have two spots at the same Z, and if you project, you get only one spot. So this is why we prefer to do 3D analysis. Yep.
There's a Florence who clicked on fill stack.
Ooh,
so
already? Okay, why not?
no, so I think it's accidentally.
Yeah, no problem.
So,
no
but
problem.
I guess Florence, you just can close your image and open it again or something like this, because obviously it's all white now.
Yeah, fill stack will fill the stack with your object. So if you want fill stack, I just so fill stack, we will see later. You select a color. The color, where's the color? Blah blah blah. Lost the color. Yeah, of course. Yeah, color picker. You select a color and then you will fill. Okay, I will destroy my image. I don't care.
No, but I think we can explain it later. Just leave Florence some time to load the image again, so she can catch up.
So yeah, careful. Fill some stack will like like exactly the same as this one. Edit fill. It will fill inside with the color yellow. So if you want to make some drawing, etc., you can do it, but maybe here you don't want to do it. What you want to do on the other hand is to have a sense of the 3D visualization of your object. So now you can click on 3D viewer if you want. So please click on 3D viewer. So the 3D viewer should appear. And now you have your object in 3D. So if your Fiji installed correctly, you should have your 3D viewer opening automatically here.
Sorry, I might have missed something a
Yep.
bit earlier on. How did you get the outline on the nucleus again?
Yep.
Just
So
real
you have
quick.
this. First, you need this one to be on. Live array should be on.
Yes.
So and then it's the thing is a bit not tricky, a bit stubborn. Yeah, you click on the object you want to see. If it's not working, just deselect and select again. So I go to another image to show you. I have another image. Just click on it. If it's not working, deselect and click again. Actually, you need to this thing select again just to update the thing. Do you have it?
It selected a another little, like the little green thing. Sorry.
Okay.
Rather than the large green nucleus.
You just have the center or something eventually. Okay, so
Yeah.
okay, so okay, okay, so
Might be
3D.
in the wrong channel. I'm not too sure.
Maybe we want to check something. So just come back and just give me 1 minute to come back to this.
Yeah, no worries.
For the 3D, everybody has the 3D viewer somewhere? Yep. So 3D viewer, you should learn how to use it. So basically, first you need to click on the hand. So 3D viewers, you need to learn how to use it. It's quite powerful, but you have some tricks you have to know. You click on the hand and then you can rotate. If you click on the zoom, it will zoom. So basically you want to rotate. So usually what I like to do, two things I like to do. First, I want to make it like a very smooth. This one, you see, you can see the pixel, you can see the different slices. That's completely normal. If you want to make it like more smooth, you just right click on it and you should have a menu. If you right click on your object, you should have like adjust slice, update volume, or maybe it's somewhere else, but it should be a right click. And then you have smooth. Inside smooth, you have smooth control. So right click, smooth control. And then you just go to iteration, just like 10. Or as many as you want.
So depending on how many objects you have in the 3D, and depending on the power of your computer, when you do the smooth control, you may need to wait a little bit before it applies, before
Yes.
you see it.
Yeah. And now you have a nice smooth object that you can publish and impress your boss. The other thing I like to do is so you think that maybe later we will detect the spot and see the spot inside the nucleus. So we need to make the nucleus like transparent. So this one is edit, change transparency. So in the 3D viewer, you have edit. Of course, you can change the color. Okay, change color. Yep. Nucleus, it should be blue. Yes, stupid dappy sometime. Okay. Okay. Okay, like this. Huh?
Thomas?
Yeah.
So someone is saying that is seeing the volume rather than the array in 3D viewer. I'm not sure what it means that volume rather than the array. This is John Alpin. I don't know if it's about surface rendering versus volume rendering in 3D viewer.
In 3D viewer, if you run 3D viewer from the plugin menu, you will have something like this. Blah, 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 display as volume. So by default is volume. But for me, since I access the 3D viewer, sorry, I was maybe a bit fast from here, from inside the 3D manager, it will call the surface rendering. So you can have the 3D, you can use 3D viewer, the normal way you use 3D viewer, but you need to use surface instead of volume.
The thing is, if you do 3D viewing, you can do a volume. You can see the volume, so you see your image. If you do surface rendering, it means that you have a binary image. That is, surface rendering means that the object is one, outside it's zero, so to say. Then if you have several objects, each object can have another color. But surface rendering is proper if you want, it's a segmentation in so to say, right? So the 3D manager will call the surface rendering automatically because in the 3D manager, you have segmented objects. But if you want to look at your image as they are and want to see all the information which is in the image, volume rendering is of course maybe better suited. Because if you launch a surface rendering, it will ask you a threshold value which cut off what is in the volume in the 3D viewer and what's off the 3D viewer, right? So surface rendering implies that you apply a threshold, and what's above the threshold is in the 3D viewer. What is below the threshold, the intensity threshold, is outside the viewer. So I don't know if it helps, but and Evangelia, Thomas Evangelia has a problem with smoothing. And Agatha also saying that smoothing is not working in the 3D viewer.
Yeah, sometimes you just need to wait. And you make sure that it's a surface. If it's not a surface, it's a volume. 3D smooth is not working, obviously. Else, I have no... And you just need to make sure you select the mesh, or you can smooth all meshes if you want to be sure. There's an option to smooth all meshes. Okay, I'll just open again. Yep. Okay, plugin 3D manager, and do it again. Chup, chup, chup. The nucleus, add image, rename nucleus. Chup. Okay, so we were to the 3D viewer. Transparency. Okay, I want to finish with this. Okay, my object selected. 3D viewer. Okay, do the zoom smooth. So for smooth, you have a different option: smooth mesh, smooth all meshes, or smooth control. Usually, I use smooth control, and then process maybe all meshes. So you will smooth everything, and then tick, wait, wait, wait. Or you can go directly to 20. And you wait. You will see a progress bar here telling you what's happening. It may take some time, especially if your computer is slow and you put a lot of iteration. So I wanted to do like edit, change, so 3D viewer, edit, change transparency, and then same, you put like usually 50. Yep. So now, yeah, you can see your viewer is transparent. That means you can see behind. So you can see the small thing we are actually are the holes inside the segmentation. So you can see inside the nucleus. So it's quite useful when you want to have some object inside other objects. Yeah.
Hello.
Yep.
Sorry to interrupt. Can you explain the part of getting the image to be transparent again?
Yep.
Like,
So you select your object. Here there's only one object. Edit. On edit, you have a lot of things. Change color if you want, and change transparency. In 3D
Yeah.
viewer, edit, change transparency, and then you. So 0 is not transparent, it's opaque, and 100 is completely transparent. So 50 usually is a good trade-off. Of course, 100 you barely see anything because it's completely transparent. Yeah.
Yep.
You should have a nice nucleus. Okay.
Also, I was just wondering how the program decides which ROI to like actually track. You know, why did it pick the nucleus instead of the various other little dots that are available?
You mean the 3D manager?
Yeah. Like when you press add image, it selected the.
Because I selected this image. I selected this image and then add image. So it will add the selected image. So now we will select another image.
Okay.
And then add image. So first we selected this one. We added the nucleus. So we select this image. Inside there are 3 objects. So object 2, 3, 4, of course, because it's the new object. And the value of the object 1, 2, 3. So we add the object from this image, then the object from this image.
Right. So this is all like already segmented as well.
Yes.
Oh, okay.
Yes.
That makes a lot more sense now. Okay.
Yeah. We will focus more on analysis. So we use segmented data first. Yes. If you give the raw data, you cannot find anything.
Okay, great. Thank you.
Yeah, you need to add segmented labeled image. So we have 3 more objects. We may rename like nucleoli. So we have 4 objects. 1 object is coming from this image. 3 objects are coming from this image. Okay? So you can do whatever you want. You can rename them and do whatever you want. Later we will add the spot or more spots. And we start with a few objects. Okay. So now we may want to do some measurement. Okay. So we are here to do some 3D analysis. So we want to do some measurement. So for measurement, it's like exactly the same as in for 2D. For 2D, you do in two steps. The first step is set measurement. So, and then you choose what you want to measure. So maybe I guess you know this one. So set measurement, what you want to measure for 2D. Blah blah, ellipse, perimeter, blah 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 blah. For 3D, it's the same. First, before doing any measurement, you say what you want to measure. So you can access this measurement thing from, you have 2 options. The first one is this, the little tools here inside the 3D measurement is the settings, the settings of the 3D manager. It's exactly the same as, I come back, plugin 3D manager option. Maybe I should write settings here. So 3D manager option or settings. It's exactly the same as this one. So maybe we use just this one. So here the measurement you want to do. So the volume of the object, the surface of the object, like the border of the object. The compactness, is the object very spherical or not so spherical? First, we will try to fit a 3D ellipsoid to the object. 3D moments a bit more advanced. Convexel is more advanced and very slow. Integrated density is the sum of the intensity inside an object, the average intensity inside a 3D object, standard deviation, intensity, the mode, ferrate. Ferrate is the largest distance between 2 points inside the object. So it's like the diameter is like exactly the same as in 2D, but for 3D. The minimum gray value, maximum gray value, the center, the geometrical center of the 3D object, either in pixel or calibrated unit. The distance to the surface, so the distance from the center of the object to all the borders of the pixel. So if it's a sphere, it should be more or less the same value. But if the shape is a bit strange, you may have different value. So it's the kind of all the distances from the center to the periphery of the object. The center of mass, the center the center of the object weighted by the intensity. Object numbering, the number of objects inside another object. The bounding box, you know, the radial distance, we see later. Closest object, the closest object to a specific object. So maybe in measurement, if you want some details, we can go back to this one. Some options. So in case you have a lot of objects, like more than 50,000 objects, more than 535 objects. If you have more than 535 objects, you cannot put all these objects into a 16-bit image. So basically, if you have more than 255 objects, you must use a 16-bit image, because the 8-bit image, we can go only up to 255. So if you have more than 255 objects, you must use a 16-bit image. And then if you have more than 65,000 objects, and people have, you must use a 32-bit image. So just to tell the 3D manager, oh, this one is a 32-bit image. Then you can exclude the object on XY, exclude the object on Z. This one, not sure it's working very well. This one, to split objects, we will see later. This one we will see later, a bit more advanced. To draw the object, so we have many options. The default option should be contour, like we saw before. Like we see the contour of the object inside the image. So sphere or point is like only the center of the object. One point, the center of the object in XYZ. Sphere is like a small sphere at the center of the object. Or you can have also the bounding box if you want. On this, a bit more advanced, we can see later. So if I just check the bounding box, okay, just for fun, but I'm sure you will prefer contour. So, okay, I use the bounding box, okay. Live array should be on. I select my object, okay. So now, you see, I see the bounding box of this object. So of course in 3D it's a bit strange, but it's a 3D bounding box. It's not like it's like a 2D, so it looks like there are a lot of space here, but in 3D, it's really the bounding box. Bounding box of the nucleus. Of course, you can select many objects together. Just control. By default, if you click, you select one object. If you control, like a list, you select multiple objects. So you can see the two bounding boxes are merged. This is normal. So be careful with this. If the two drawings are merged, the borders are merged, you will see the merge array. So, but maybe I'm sure you prefer the contour thing. Up. So I selected the three objects. I can put it on the So I can change an image. Okay, click on another image. Maybe I need to select something else. Okay. Up, up. So now I see the borders of these three nucleoli on the first image. Okay, are you okay with the visualization? Okay, so now we want to do some measurement. Yeah, any question? Yeah.
Maybe I can add something to,
Yep,
so it's really
please.
clear for everyone that so first of all, you have a region of ROE is for region of interest, and you have a region of interest in ImageJ Fiji, which is a basic one. If you find it in Analyze Tools, right? This array manager. The point that it's only working is in 2D. So if you use this array manager, like the one Thomas opened, if your object is your object will be like in 3D, and basically this 2D manager will make one region of interest for each image of your stack, right?
That's
While
nice.
the 3D manager will have one region of interest for the whole 3D object. That's the key point here. The second key point, which is true for either for 2D and 3D region of interest, is that once you have a region of interest, you can project this region of interest on any open image, which is what Thomas did. That is, he had three regions of interest coming from one image, and he projects them onto the other image, right? So you can really analyze what's inside the region on any other image which is open. So, because once you have the segmented, you don't have the intensity values anymore because it's segmented, it's binary image. So you project it again to the original image, so you get the intensity. Or you can project it to another channel, so you extract the information from the other channel. That can be of interest because if you imagine you have double labeling, that is, you have two colors, right? And your cells are in two colors. And for one color, you have a really good signal, and the other color is not so good signal, but you want to, but the intensity of that signal is of biological interest. You can use a good signal to extract and to find the region of interest. And once you got them, you can project them on the other channel, and so you get the intensity of the other channel. I don't know if I was clear with that now, but like usually if you, for example, you have a DAPI staining, so you have your nuclei, so you can easily like threshold those nuclei, find identify the nuclei, and then you can measure within the nuclei other intensity coming from another channel. That's
So the idea is like you have to separate. Once you have a multi-channel image, you have to separate the objects from the image. From one image, you may have multiple objects. So you need to say, oh, what are my objects, or how can I detect my object? So to detect my nucleus, I use this channel. To detect my spot, I use this channel. Eventually, inside the nucleus, you may detect two kind of objects, like the nucleus and then the heterochromatin region, the region that are very, very bright. Some people can do this. So you have to separate the channel and the objects. And then because the analysis it's focusing on object, so usually one channel, one object, but maybe sometimes it may be a bit more complicated. But this is the idea. So this is my raw data, and this is my object data, and kind of separated. So and then so here we have the information of where are the object, and here we have the information of the intensity inside the object. You cannot have both at the same time. You must have the object on one image and the intensity on another image. You must have two different images, the raw data and the segmented data. Else you cannot do any analysis. So we try to do some analysis. Nicolas, 1, 2, 3. So we wanted to do some measurement. So you select the objects you want to measure, and then just click Measure 3D. Okay, quite simple, right? Just click, zoop. So now you have a bunch of measurements. Yep. Okay. Select your objects, measure 3D. So you can see you have the NB is the line number, the name of your object, the label of your object. So the label of your object is the original value. 1, 2, 3. Label. What is label? I don't know. Cannot remember. Maybe just 1, 2, 3. The original value of the object in the segmented image, I guess. The type we will see later. The classification. CY, CZ, CX is the center of the object in pixels, CY in unit. You will see many measurements, and it will tell you if the measurement is unit or pixel. And then after you have volume, VOL, volume, in unit. So using the calibration, the XYZ the calibration of the voxel. In 3D, we talk about voxel. On the volume of pixel actually is just the number of voxel for my objects. And you see, you multiply this by this, you multiply the number of voxel by the volume of one voxel, you go from this to this. So surface is a bit more complicated to compute, like the volume of the border. It's a bit tricky usually to compute, but you can get some ID. So the surface in unit, the surface in pixels, quite different. The corrected surface, try to smooth a bit the surface. When we use 3D viewer, we saw it's like steps. So we kind of smooth a bit the surface. We can have a better idea of the surface. Compactness. So using some pixel value, sphericity, compactness using corrected surface, sphericity using corrected surface, compactness using unit value, and so on and so on. So all this comp sphere should be quite related. They try to measure the sphericity of the object. The object is very spherical or very compact. And maybe one that's quite accurate, maybe it's like compactness discrete compactness. That eventually, because the compactness is very dependent on the noise of the object. The objects are not smooth. So by default, there are some X, Y, Z, it's an integer, so it's not smooth. So it's quite difficult to find a really good measurement of the surface, hence the sphericity and the compactness. So you have, depending on your object, you may choose one measurement or another one of measurement of compactness. So all this thing is related to the shape of the object, the compactness. Everything with L is ellipsoid. So this is related to ellipsoid. Ellipsoid, the measure radius in units. So you fit one object with an ellipsoid and you get the measure radius, the main radius of the ellipsoid. The elongation is the ratio between the measure radius on the ellipsoid and a second, so it gives you the elongation of the ellipsoid. Flatness is the ratio between a second radius of the ellipsoid and the third. The volume of the ellipsoid, that should be more or less the same as the volume of the object, and the ratio between the volume of the object and the volume of the ellipsoid. So closer to 1 means the object is closer to the ellipsoid. And DC is the distance to center. So you imagine, you measure from the center, you measure all the distances to the border of the object. So you have a lot of distances. So you take the minimum value of this distance, the maximum value of this distance, the average value of this distance, and the standard deviation of all these distances. So the min max. So for this one, the minimum should be like something like this. The minimum distance to center, the maximum distance to center, and of course the average distance to center and the standard deviation. So give you an idea of the kind of the average radius, the shape. If the mean and max are very different, mean the object may be very elongated. If the minimum value and the maximum value are the same, the object is very spherical. So you have a lot of information about the shape of the object. Is it clear?
Can you repeat the flatness for Agathe?
Flatness is this one. So you feed the object by an ellipsoid. Yep, this one will be very bad, but yep, it's better, of course. But so you will get the major radius, the second radius, and the third radius in 3D. So elongation is the ratio between the major radius, the radius number 1, and radius number 2. And flatness is the ratio between radius number 2 and radius number 3. So yeah, if you play like rugby or this kind of thing, your balloon can be quite spherical, also quite flat. So this is the ratio between the second axis and the third axis. Are you okay? So already you have the volume that can give you a lot of information. So volume, just classical volume. The compactness, sphericity is more like the shape. Ellipsoid, also the shape based on ellipsoid measurement. Everything here is about the shape. So depending on your object, you see one is more robust, one is more accurate than the other one. It really depends on the objects. The only, yeah, okay. Yeah, the volume here is very simple to compute, of course. Okay. So now we want to measure the intensity, the average intensity of a nucleus signal inside the nucleus. Okay, right? So the object of interest is the nucleus. The image with the information, the intensity we want to measure is this one. So you want to be sure you can just, okay. So we will measure the intensity inside the object, nucleus, the intensity coming from this image, from this channel, the values here. So just quantification 3D, just, okay. So you select the object, one or many object, you select the image with the intensity and click quantification 3D. Yep, and the same. So you will see something here. Since this image has many channels, it just tell you that it will just measure the intensity into channel 1. Later we will do intensity into channel 2. So here, so we have okay, the name of the object, label at center, so the intensity at the center of the object. Yep. The center, what we call the center of mass. So this is the geometrical center weighted by the intensity. It should be more or less the same at the center, than the geometrical center. Integrated density is the sum of all the intensity inside the object. So here you have intensity, I don't know, 112. Here you sum all the values inside the object in 3D. So this is the integrated density. And now you have the average value inside this 3D object, the standard deviation. This we will see later. Okay. So now I do the same, another channel. I want to measure the average intensity of the spot signal inside the image. So I just change channel inside my image. On the same quantif 3D, I have another window. So now the same object, but the value is completely different. So we measure the intensity inside the object. Yep, you really need to be careful. The contrast. So now it's the intensity inside the object nucleus, but intensity values will be from this channel. Okay. So we will play with this one, if you're okay. So we will do the same for these three objects. 1, 2, 3. I don't know why you need to update a bit. So I selected the three objects. I selected the channel 3 inside my original image. And I want to measure, yeah. Question? I want to measure the intensity of the three objects inside the three object for the signal nucleolus. So same, I select the three objects, quantification 3D, zoop, et voilà. Okay, so now I just want to show you that you can play a bit with this table. So if you want to sort the object, which object has the highest average intensity? You just click on mean and you can sort the values. What value has the maximum integrated density? The total intensity inside the object. Just click on it and see so this is object number 2. Let's say we have many objects, so you can also select some lines. Okay, let's say I want to select yep, and take the mean. Okay, all these two have average intensity above 90. I want to select them. I can select them, and then I can just go to menu. No, it's not working here. Okay, not working, sorry. It's maybe a wrong version. Okay, whatever. We do something else. Of course, we can save. We can save this as a CSV file you can open with Excel, no problem. You can save this like any result table. You can save the selection, so only the lines you selected. So it's kind of a result table. But yeah. Okay. So, yeah. Okay, so maybe we play a bit with distances, and then after we could have a break, maybe after 2 hours. And after maybe Nicolas, after the break, Nicolas can talk a bit more about distances and colocalization. So, what I want to show, yeah, I would like to show something. I want to measure. Okay, go back to measure. Yep. Yes, yeah. So in measure, let's say I want to see what is the biggest nucleolus. So I go to volume, pixel or unit, and then I click. Okay. So I know already it's nucleolus number 2. But if I'm a bit lazy and if I have like a 20 or 100 or 1000 object, I click on the object I'm interested in, menu, and then I have show objects. So I'm not sure it's working, so just check. Yes. So automatically it will select the objects corresponding to the selection here. So there's a kind of synchronization between this and this by this show objects. So let's say you do a lot of measurement, you have a lot of objects, and then you see, oh, what is the object with this measurement? So you just show object, and it will be highlighted into the list in the 3D manager. Yeah. Are you okay? Okay. So before the break, so a lot of people may ask me, can I save this? Can I save this image with the array on top? Yes, you can. So the idea for this is to use another plugin 3D.
Wait,
Yeah.
there's a question. Someone want to see again the show object.
Yep. So you need to select the 3 nucleoli. It's only working for measure. It's not working for quantif. It should work for quantif, but maybe I forgot to do it. So in the measure 3D, so you have some objects. So what I did is just sort the object by volume. And then I select 1 or 2 lines or whatever. Select, let's say, the first 2 objects. The 2 biggest objects. In menu, so you have save selection, and show objects. And here you will see the selected object actually. The object you selected from 3D measure will be selected, highlighted into the list of 3D manager.
Of course, it looks a bit strange here because we have only 4 objects.
Yes.
But
Yes.
if you have, I will show you images where we have
Yes.
thousands of objects. So if you see something interesting in your table, you say, "Oh, this object I want to see." This is very practical because otherwise you will have difficulties to find in the huge list of objects. Because once it's highlighted in the 3D manager, then you can see it on the image, as you can, yes, here. Voilà. You see now the 2 array are highlighted in the image. So the idea is really to have a convenient way to pass from the numbers, the results, and the image back and forth.
So something else you can see, if you think that visually, let's say, yep, nuclei 1, 2, 3, you see, maybe you say this nucleolus looks strange, look brighter than the other 3. Just visually, just manually. So there's some kind of stupid manual classification. You can select one object, and then you go to your keyboard, and then you click from 1 to 9. So I select one object, and I select like 1. Oops, okay, don't worry. And then, okay, whatever. So that means now I have kind of classification. So you just go, you select your object, and you press on your keyboard 1 to 9. So it's kind of manual classification. Oh, I think nucleoli number 1 is, maybe I should put like class 1, and the nucleoli 2 and 3 should be like class 2 because they look similar or whatever. Or I want to do something, I want to remind me that maybe, this one may be specific and these 2 I put together. So it's a simple, very simple manual classification, just to put some tags onto your object, so you can remember later. And then you do the measurement, and this is called type. Yeah, the measurement is called type. It's classification or tag. Maybe it should be called tag. It's called type, but it should be called tag maybe. And then if you want to untag, just check your object and press 0 on your keyboard. Right? Yes. Okay, don't worry about this. Okay.